Hi guys, my name is Bart Basens. I'm a professor of Big Data and Analytics at the Catholic University of Leuven in Belgium and a lecturer at the University of Southampton in the United Kingdom. Recently, I teamed up with my colleague Professor Seppe van der Broeke, who is a professor at Ghent University and also here at KU Leuven University, to write a book on managing model risk. The idea for writing the book basically stemmed from the fact that throughout the past few decades, both Seppe and I collaborated with quite a lot of firms worldwide. More specifically, we collaborated with retailers such as Coca-Cola, Amazon, Facebook, with various types of banks such as Bank of America, HSBC, with insurance providers, with governmental institutions like the US Census Bureau, the US Marine Corps, and so on. But besides collaborating with firms, we also were actively involved in doing research on analytics and developing new algorithms and trying to come up with innovative applications of those algorithms. And throughout our industry experience and research, we often encountered the fact that the implementation or the development of analytical models comes with a certain amount of model risk. Hence, the idea of writing a book on this very important topic. Here you can see the website of this book, and basically, if you go to table of content, you can look at the table of content. Like any good book, we start defining model risk, and in this book, we kind of define model risk as the risk of expected or unexpected loss resulting from the inadequate development or usage of analytical models in any type of business setting. Very important to be aware of is that we do not only focus on financial business settings where you see a lot of model risk being addressed nowadays, but we kind of zoom out also to other types of settings such as marketing analytics, production and logistics, analytics in manufacturing, analytics in HR, and so on. So after this first introduction, we give a very brief data modeling recap. And this is very high level, so the book is also targeted to C-level executives. We give a brief high-level overview of different types of data, different types of learning, like supervised and unsupervised learning, the key criteria of predictive models, like the fact that they should be interpretable, that they should be adequate, that they should be useful, and obviously valid, and so on. Then we zoom into various types of model development processes, like the KDD process model, the CRISP-DM model, which we very much elaborate on, and also the SEMA model, for example, proposed by SAS. We then zoom into various types of risk, starting with the data. We discuss data bias, the data perimeter, the very important concept of data quality, what to do in case you have lack of predictive power, how you can deal with that. This is a situation that is often encountered by many firms nowadays. What if you have external dependencies, if you rely on external data provided by Google, provided by social media platforms, provided by data poolers, etc. We then go into specification risk, and I just highlight a few things, right? I'm not going to go through all the sub bullets, but just highlight a few things. Then we elaborate on specification risk in chapter 4, how to define your targets appropriately, like if you want to predict churn, how you can do that appropriately, because there are various types of churn, active, passive, forced and expected churn, for example. We talk about uplift modeling. We extensively talk about improved loss functions because if you look at many analytical models nowadays, they are typically optimized using a mean squared error or a log likelihood based error measure. But this is not what businesses care about. As a business, you care about shareholder value or profit. So you can directly embed that profit in your loss function, which is also something that we extensively discuss. For reinforcement learning, it's very important to come up with good digital twins in order to be able to do good simulations. And oftentimes we find that this is not as obvious as it sounds. So that's why we also talk about buggy digital twins. We then also elaborate on the development risk. What are the types of risks that may pop up during the development of your analytical models? We talk about data leakage and we kind of decompose it into instance leakage, where you have instances leaking between your training and test set, and feature leakage, where you have a feature that is actually, for example, measured after your target variable was measured, which is something that should not take place if you do adequate model development. We talk about programming errors. What about assumptions? We all know that analytical models oftentimes rely on assumptions, but these are only seldom satisfied in real life. So we talk about how to deal with that. We talk about what's the risk that comes with developing analytical models in isolation. We talk about the risk of losing the end users, vendor lock-in, where you get too tight a connection between you and your software vendor. And obviously, we also extensively zoom in on the choice between open source versus commercial software. Then we have validation risk, test set torturing. We've seen many times in industry when we either validated or inspected analytical models that people oftentimes torture the test set in the sense that they make the test set an active part of the learning process, which is something which is not meant to take place. So we elaborate a bit on that. We discuss the subtle difference between generalization and overfitting, the unexpected science problem, like suppose you have a logistic regression model that says the higher the level of depth of a person, the better his or her credit worthiness. That's a very unexpected, counterintuitive science. So how to deal with that? I'm just highlighting some things. We talk about issues that pop up when interpreting interpretability techniques using, for example, Lime, Shapley, partial dependence plots, or ice plots. Why complex, uninterpretable, or black box models like deep learning may still make sense in settings where interpretability is required, like credit scoring. We talk about model benchmarking, comparing models so as to continuously perfect them, calibration, and how to set up a good model auditing infrastructure. Um, Operational risk is also intensively discussed. Drift, data drift, what happens with your analytical model as your data that you're witnessing right now starts to drift away from the data that was used to develop the model. What if you have output drift? If you have your output variable all of a sudden starts behaving different in terms of distribution than the one that you witnessed during development. We talk about technical failures, model overrides, and model retirement. Model retirement is going to address the issue of what to do with your old analytical models. Should you just drop them, or can you let them retire in a model in a model repository, and as such, maybe use them in a meaningful way later on. We talk about security risk, like model outsmarting, a problem which is particularly important for um, um, fraud analytics, where fraudsters try to continuously outbeat analytical models by coming up with smarter fraud mechanisms. We talk about model backdooring, model exfiltration, where you try to learn an analytical model using just an API, for example, and denial of prediction attacks. The book then concludes with discussing managerial risk, how to transition from one analytical model to another. What about different types of regulations and ongoing changes in regulation? Model ethics is very important nowadays, but also model anxiety, because we kind of witnessed anxiety of analytical models at different levels, at the level of the model users, as well as at the level of the subjects, like employees, which are being scored by an HR analytics model, for example. Climate change and ecological risk is also discussed because may not seem that obvious, but actually, when you think a little bit more careful, also climate change and ecological risk have an impact on your analytical model. And we finish off with discussing the time for a chief model risk officer. In case you're interested, have a look at our website. It's managingmodelriskbook.com. In case you're interested, the book will become available in a month from now, and you can sign up at our homepage. Here, you can enter your email address. You can sign up right there, and then we'll let you know. And obviously, as the front cover, we picked the Tower of Pisa. I guess it's pretty obvious because it's the utmost, most important, most illustrative example of how to deal with model risk. Thank you, and hope to hear from you soon.